When two hydrogen atoms collide, they join together to make an H2 molecule. We'll show this join as a bond between the atoms. You can also see the unused bonds on the separate hydrogen atoms that haven't collided yet. When another hydrogen atom crashes into the molecule, it doesn't stick because all the bonds inside the molecule are used up. A box full of hydrogen atoms will quickly turn into a box full of H2 molecules. It's similar with oxygen atoms inside a box, except that oxygen makes two bonds with other atoms. When they collide, they join to each other twice to form a double bond. A box full of oxygen atoms will quickly turn into a box full of O2 molecules. H2 and O2 molecules will stay that way unless we do something to change them. What if we put one hydrogen molecule and one oxygen molecule in a box together? In reality, a box filled with gases would contain trillions of molecules. But we just want to look at the action of individual ones. What will they do? Well, we know that they will move in straight lines, and they will crash into the walls and bounce off again. But what happens when they collide with each other? Nothing. They just bounce off. Well, that's not surprising because the molecules are using all their bonds and don't have any left over to reach out and join to other atoms. But what if we light the gases with a flame? Whoa! What happened there? The hydrogen and oxygen molecules busted apart into atoms, and then the atoms rejoined to form a different molecule, H2O, and a leftover oxygen atom on its own. Why did the flame make a difference? And why did we get a new substance? We'll replay this and slow it down so we can follow it. Have a close look at the molecules when we bring in the flame. They speed up. That's what heat is. The hotter, the faster. And when these faster molecules crash into the walls, or each other, they bust apart into atoms. Now that the atoms are on their own, they are free to join to other atoms. And they can join with different ones. Here, one of the oxygen atoms has bonded to both of the hydrogen atoms. And because its valency is 2, it has no unused bonds left over. But the other oxygen atom missed out on getting any hydrogens at all, so it's got 2 unused bonds and is on the lookout for other atoms to join to. And we'd run out of hydrogen atoms because we only started with 2 and the other oxygen got them both. But we can fix this by putting an extra H2 into the box at the beginning. Let's do that and light this candle. Nice. That was even louder. Now both oxygens have the 2 hydrogen atoms that they need, and we end up with 2 H2O molecules. Water wasn't there before, so a new substance has been made. Not only that, the old substances have disappeared. This rearrangement of atoms to form a new substance is called a chemical reaction. We'll replay this chemical reaction to show 3 snapshots in time as it goes through different stages. At the beginning, there were 2 H2 molecules and 1 O2 molecule. These starting substances are called the reactants. When the flame busted them apart, there were 4 separate hydrogen and 2 separate oxygen atoms. Then each oxygen atom joined with 2 hydrogen atoms to make 2 H2O molecules, which are called the products of the reaction. We'll now show how the old bonds break and the new bonds are made. To do this, we'll use structural formulas which show the molecules as symbols joined by sticks. When the reactant molecules are pulled apart, the bond inside each H2 and the double bond inside the O2 are broken. When the H2O products are formed, 4 new bonds are made inside their molecules. The H2 and O2 have disappeared and are replaced by the H2O. A new substance has been formed, so this qualifies as a chemical reaction. But the molecules in chemical reactions are too small to see, so how can we tell if one's happening? Well, any evidence that shows that a new substance is being made, or that an old substance is disappearing, indicates that a chemical reaction is going on. Telltale signs include a colour change, a cloudy precipitate forming, bubbles of gas, a new smell, or a solid dissolving. The breaking of old bonds and the forming of new bonds changes the energy inside the molecules too. So heat, light, and noise can also be signs. If the bonds in a reaction release energy, this goes into the surroundings and heats them up. A thermometer shows this as a rising temperature. A reaction that releases energy is called exothermic. If the bonds absorb energy, this is pulled out of the surroundings and cools them down. A thermometer shows a falling temperature instead. A reaction that absorbs energy is called endothermic. Each reaction is unique and has its own combination of signs. Different chemical reactions are happening everywhere all the time. Right now, the bonds of the molecules inside your body are being broken and new bonds